Good morning, everyone. We will start in a few seconds. We still have people coming in. Okay, so we wait 1 second, please, before we start. Good morning, everyone. Douglas, okay, I see you here, but not with me. Let me check why. A second that I pull you up here. Okay, so perfect. So Douglas is here with us now. We can see you on a camera. Good morning, everyone. So welcome to this EWA IFAT webinar on harnessing artificial intelligence for water, listen, learn, and future horizons. I will start with a few slides about IFAT, EWA, and a bit rules for today, and then we will dive in directly into the first presentation. So the first one will be done by Claire, then Douglas, and then we'll have Sotirios with us. So IFAT is, and especially IFAT Munich, is the most important industry meeting point in the heart of the largest international platform for environmental technologies. They are expecting from May 4th till 7th this year in Munich over 3,000 exhibitors from more than 60 countries to present their strategy and innovation. And one of the focus is water, recycling, and also circularities. It's also a place where municipal and private sector can talk about water management and relating issues. EWA is always strongly present there. And this year we will have AI and water sector as sessions there. And therefore we are also doing a webinar to already start a discussion about it and to let you know about IFAT and EWA activities. I'm not sure if some of you joined. We already had a webinar on water reuse, and we'll have one about desalination next month. So if any those topics for water reuse, you can watch the replay online, and for desalination, you can join us next month. And we have an EWA code to get a free ticket to IFAT. And I would like to thank the speaker again for joining us today, and we'll kick off this AI in the water sectors topic, and that will lead us to IFAT in May next, later this spring, sorry. So EWA in a nutshell, in case you do not know us already, we are an independent, non-governmental and non-profit organization dealing with the management and improvement of the water environment. So we have members from nearly all European countries. So have national members, corporate members such as Suez or Bentley, and research member. And we aim to provide a forum for discussion on key technical and policy issues in Europe. So key technical as today, and we are also involving on following up, for example, the Urban Wastewater Treatment Directive, implementation, supporting the Commission by inputs, providing inputs and so on. And we aim to, and we do all of this, share our knowledge and our member knowledge via conference, workshop, meetings, and so on, such as today, just in a really short nutshell. Regarding today, I think a bit more important. So you can use as a chat box. I saw that some of you already posted. Please use the Q&A box to submit your questions to the panelists because you cannot switch on your camera. Douglas, correct me if I'm wrong, but normally all of our speakers agree to share the presentation, and this
yes,
today's webinar is being recorded and will be available on our YouTube channel. in the upcoming days. And without any further ado, we will start with Claire for her first intervention. And Claire and Mathieu, from CS, you have experience in telecommunication, IoT, biometrics, and big data. You focus on leading the adoption of AI and data projects that support sustainable innovation. You are data and AI director at Suez, and you develop practical AI solutions to improve water and waste management to protect water resources and decrease environmental impact of our activities. So Claire, you have 7 minutes, and I will be sharing your slide from my side. So just let me know when I need to go to the next one.
Okay. Hello. Thank you, everyone. Good morning. And thank you for inviting me to this roundtable. So, yes, I'm Claire Mathieu. I'm the head of data and AI at Suez. For those who don't know Suez, Suez is a global leader in water and waste management sector. It's operating in more than 40 countries. And we are distributing drinkable water for around 68 million inhabitants around the world. So I'm here today to share with you some insights on how to use artificial intelligence in this domain. And I will start by a little bit of context. I think you need to, yeah, thank you. So, as you know, the water sector is under more pressures than ever. Those pressures are driven by various factors. One of them is, as you know, the impact of climate change, which is intensifying both water scarcity in some region of the globe and water-related disasters and floods, as you can see in the news very often. In parallel of that, you have an increase of usage and withdrawal of water from nature, and this usage is increasing. One example, unfortunately, is the impact of the use of water for data centers. I read recently that the forecast of data center needs in water is more than a European country like Denmark in the next few years. So huge amount of water needed for agriculture and industrial as well. And another pressure on our precious resource is diffuse pollution. And you know that we have more and more challenges around detecting pollution and treating it. So if we move to the next slide, with this context, what are the main challenges that we have in water management today, and how AI can answer some of them? The first one is that we need to secure water resource. If water resource is rare, we need to secure it and to make sure that we can distribute it to the population. So to do that, we have to protect the resource and make sure we don't lose it. You are aware that in some countries and in Europe as well, 20% of the withdrawal of water from nature is lost in leaks, in water leaks. And there are some countries around the world where this figure goes up to 50%. So we need to secure that. We need to stop as much as we can water waste from the withdrawal. The second one that you know if you work in the water sector is the huge challenge of aging infrastructures. We have in Europe more than 4 million water distribution pipes, enough to go to the moon 5 times. And those pipes are aging. They are 50, 60 years old, and we need to find a strategy to renew those infrastructure very fast if we want to prevent water resource and also manage correctly our budget, right? So renewing infrastructure is a huge challenge coming ahead of us, and we need to plan it, and we need to focus on where to start, and what are the main the most critical part we should renew first. And the last one, of course, is that we need to ensure service continuity whenever extreme climate events occurs, or pollution peaks and things like that. We need to make sure we deliver water on 24/7 in the expected quality. All of those challenges should not be treated separately. They are all linked together, and where AI and data can help us is to make sure that we can use the data from all the infrastructure and the operation that we perform to find solution for those challenges. So let's go to some concrete example. So we are kind of lucky in the water sector, is that compared to the waste management where I work for as well, we started to collect data from sensors, from plants a long time ago, and we also start to have data from smart metering. You know, we moved from a vision of water consumption of once in a year to once every minute. So we have a better knowledge of our the consumption and the life of our assets. And thanks to that, AI solutions can be a real powerful tool to overcome the challenges that I just mentioned before. So I'm just gonna give you for example, because I only have a few minutes, but if after the session we can go deeper into one or two solutions if you want. So coming back to the challenges we have, first one, protecting water resource. There are, I would cite two main applications, but there are so many. The first one is to use AI from data from sensors that we have on pipe to train a model to detect a leak earlier, as early as possible. And this is really possible thanks to the artificial intelligence, because we have some data coming from the fields, and we are able to provide a signature of the signal of a leak, and that can be helpful to augment and to support the people on site to detect a water leak much earlier than what they used to do manually. So this is one, for example, and it is a really a field where there are many applications being developed currently. We also have some startup working on analyzing satellites video and automatically recognize water leak when it's a little late, but still, so start to be efficient as well, and very other promising technology on that one. When I go to the infrastructure challenges, the renewal of infrastructure, so we are able now to get data from the field, and as well as the geographical data, the soil information, the weather forecast. And when you cross all this information, you are able to predict what are the pipes that are likely to fail in the future. So this is where you will focus for your next operation on the fields. So there start to be application for that will help you better plan your infrastructure, the infrastructure renewal. We also have some tools now capturing also data from real time from the field as well, uh, helping us to plan better the future deployment of infrastructure in a country, depending on weather forecast for the future and prediction, using all kind of open source data and combining it with all kind of physical models. We can be able to have some tools to help you better plan, better optimize your infrastructure plan. The one about reducing environmental impact, yes, we are working so that the plants we are operating are consuming less and less energy, which is an issue, a geopolitical one. Less energy, less chemicals. So for that as well, AI start to be powerful. It used to be done with some expert rules, and now more and more we use data from the current operation plants we operate around the world to train models and be able to optimize the way we use energy in a water treatment plant. And the last one I will say that comes with the new revolution coming ahead of us with the arrival of generative AI. You can use now generative AI to extract knowledge, to translate knowledge, to share knowledge very more easily than it used to be. And when you know in the water sector that we are lacking experts and lacking operator and we need to face the retirement of our employees and things like that. So sharing knowledge and make it available in all language and share the expertise via a generative AI tool is going to be a game changer as well in the way we operate, in the way we train our employees, etc. So you start to have some assistant that allow operator to have the best and the most accurate information in a quicker time. So all of these solutions are just a very quick overview. I could talk about each one for some times. I will leave the panel for the others, but I can come back to you with more precise info if you need.
Thank you very much, Claire, for the presentation. Yeah, we will come back to some of the points that you mentioned, I'm sure, during the discussion. For our audience, please do not hesitate to use the Q&A section if you have any questions for Claire. Our second speaker will be today Douglas Miranda. You are a solution architect who implement end-to-end solution for water utilities, spanning digital twins for non-revenue water reduction, real-time network monitoring, asset management workflow, and infrastructure design. You combine an MBA in data science and analytics with deep hydraulic modeling experience for water supply and wastewater network, integrating SCADA, IoT, weather, and GIS data to deliver actionable operational insights. You work for Bentley System, and Douglas, the floor is yours. I think you share your presentation directly, right?
Yes.
Okay, so let me stop sharing, and the floor is yours. 7 minutes. Thank you.
Thank you. So I'm sharing here my screen. Can you see it?
Yes, we see it on full presentation mode.
Great. So I brought here some examples of technologies and capabilities developed by Bentley applied for water. So that uses AI. So these capabilities are a mix of agentic and generative AIs. So I brought here 4 examples, starting with one capability that is the Copilot chat developed by Bentley, which is an agentic AI that is being developed for the engineering applications in Bentley. So it helps specifically engineers that design and analyzes water networks to understand and access results, helps to with repetitive tasks and during this type of works. And the second case that I will be illustrating is an AI tool that helps a lot during the digitalization phase of a water utility that is evaluating the best optimal places to install pressure sensors, which is an AI-based tool that helps utilities during this phase. And the third one is it's a very interesting tool that uses generative AI to detect anomalies on operations, which includes detection of leaks, but also detection of any types of operational outliers like illegal discharges, combined sewers overflows, changes in the water quality, and so on. And the last one is a game changer, in my opinion, which is the combination of detection of anomalies together with the uses of evolutionary AI to geolocalize leaks in networks. So I'm gonna here quickly show some videos about which one, starting with the chat. So in this example, I brought here a model of a stormwater network, and then we can use the agentic chat to ask some questions like how many manholes we have or by different depths, so we can help summarize in networks like this, or give me the list of all gravity networks and the following slopes, and also asking, are these at the current evaluation, are they following the local design or standards, so we can attach documents with the local ISO rules, and then they can say, yes, we have conduits that's not following design rules. So this is an application of an AI chat applied for stormwater. The second case I brought here is it's an AI-driven tool to help you to analyze your current assets for the water distribution system, and AI tool can help you to show and point what's the best places to install pressure sensors to better manage pressure zones and DMA. So it leverages data from hydraulic models using also AI algorithms to evaluate the existing sensors and also the assets are among the network, and then it exports to you some suggestions of placements for pressure sensors. The third case is the anomaly detection is something that is widely used currently, which is the integration of historical sensor or combined sensors data, and then the system can read real-time and historical data and analyzing seasonality, weather data, and past operations. It can detect the next day's patterns, and then we can use those patterns to detect automatically outliers. In this slide, I am illustrating with a case of a burst, but it can be used to other things like the problems with the setup in pressure reducing valves, or problems related to water quality or pollutants in wastewater systems. So it can be used by many applications. And the last one connected to this, we have the connection between generative AI and the use of evolutionary algorithms, that is another AI component, to geolocalize leakages. This is an illustration about these two that we are now developing, and I have here at the end a use case from water utility. So it's an algorithm that uses evolutionary deep learning, and then it tries hundreds of thousands of interactions to find what is the places that are more let's say accurate to represent the leakage. So it uses the anomaly detected, illustrated by the third cases I just shown, and then it starts using the evolutionary algorithm to first doing an automatic model training, combining sensor, hydraulic models, and so on, and then it starts doing the prediction of the best locations of the leakage. So at the end, it reports you, after using the AI, what's the places. Then you have a better, let's say, a better approach. So it's how AI can help you to not only to get insights, but also to use insights to transform into intelligent actions. So in this example, we are using a technology by Bentley that connects with our digital twins platform. So the Bentley's digital twin platform is WaterSight, and this tool is the Anomaly Leak Finder, or ALF. So in this use case from the PUB in Singapore, we had in this project leakages detected, and then the tool helped to narrow down the people in the field to find the leakages. So we had detected leaks within 220 meters area. So it's a very assertive way to help water utilities to find leaks, geolocate leaks. So we can detect and also help to geolocate leaks. So these are the 4 use cases that I wanted to illustrate before the roundtable with the audience. Thank you, Arthur.
Thank you very much, Douglas, for this hands-on presentation. Before I give the floor to Sotirios, we had quickly just a question, maybe yes, no, that we can develop later, but we had, does Bentley also provide AI-driven solution to sewer networks? Maybe yes, no, and we can tackle it later on, but at least it's a quick reply if you want, Douglas, in a minute.
Yes, so here I brought just 4 examples due to the time, but Bentley also provides AI tools for asset maintenance for sewers as well. So our platform is for both water and wastewater networks.
Okay, thank you. Maybe we'll pick it up on it later, and Claire as well.
Yeah, one of the application I wanted to talk about also in wastewater, what we see now is new tools, new drones for wastewater inspections. So you use drones like boats or boats navigating in the pipe, and you capture the data, and you can, and from camera and AI computer vision, you can detect, for example, anomalies in the pipe. So you better, when you cross it with GIS data, you can better identify where the anomaly in the wastewater pipe can be. This is one example.
Thank you very much for the precision, Claire, and Douglas for the quick reply. We can discuss it after it. Now we move to our next speaker. So we have Sotirios Kanellopoulos with us. You are a policy officer working at the Directorate General for Environment of the European Commission. Thank you for being with us today. You worked at the intersection of data, digital technology, artificial intelligence, and environmental sustainability. And you are a computer engineer and data scientist by training. So now saying you have, I think, 5-7 minutes up to.
Yes.
If it's shorter, then please, as for you.
Yes. Well, Arthur, thank you very much for the invitation. And thanks the other speakers and panelists for the great presentations. Well, I'm going to step back a little bit from the view. The view I'm bringing in is the policy view. So I'm going to do 2 things. I'm going to very briefly present the assumptions we currently make when it comes to AI and water. And then after that, I'm going to link them with some kind of policy actions that we're currently taking. So the first 3 assumptions we do on AI and water at the moment is that, first of all, of course, AI and water was here before ChatGPT went out 3 years ago. With a lot of applications in several domains like predictive maintenance, leakage detection. The previous speakers presented many of them. The question that we would like to see and ask at some point is to what extent the market is moving to what happened in language or what happened in computer vision with foundation models, actually replacing specialized niche models and be able to create a new markets based on those foundational models, as it happened, for instance, in language-based applications or in computer-based vision applications. That's one of the things that we are looking at and trying to see how the market behaves. And of course, inputs from this panel and from this group would be very much welcome. Then the other 2 points we're looking at, of course, besides the corporate applications and the custom applications that the other panelists presented, which are very important, we also look at the low-hanging fruits, and there are many tools available out there for anybody to use. They can produce Python codes, they can do time series analysis, they can offer low-hanging fruit applications at the moment. The question is to what extent those applications are validated, to what extent water utilities, smaller water utilities, or practitioners can use them directly in order to carry out routine tasks. We believe that it would be interesting to look at the skills part and qualifications part and validation part of best practices in the field, so to ensure that people use them safely, but at the same time reap the benefits of them. And the last part is, of course, what we have been listening the last half an hour from the other panelists about the custom applications, corporate-based applications, agentic applications, AI agentic applications, where you have all these different agents handling digital twin models, language interfaces, and I think these are really, really huge advancements for the water sector. And I also heard Claire saying before about being able actually to accumulate all this tacit knowledge from the past in those models and be able to transfer it. I think it's really key for the water sector part. Now, on the policy actions, so we're looking a little bit the AI stack from the bottom, from the hardware part and going up to the application area. I would like to bring to your attention the initiatives that we have on the AI factories and AI gigafactories, where we actually offer to startups, to academia, computing power, processing power, to train or inference for their models. We also had the Apply AI strategy that came out earlier last year, focusing on use cases in different application areas, including environment. And there's a reference to digital twins and Destination Earth, and hopefully I can come back to that later. But we see that digital twins are reinforcing their roles now in the AI area as world models, where they can help the models prevent hallucinations and validate the results. And last but not least, definitely we have the water resilience strategy, where there's a specific, let's say, thematic area on AI and digitalization. And there will be a call for evidence actually on the digitalization action plan coming out very shortly, where, of course, we would like to invite the community to provide their feedback on how they see this digitalization action plan should take into account developments in AI and AI applications for the water sector. Next to the digitalization action plan, there will be also a strategy on water resilience and research and innovation, but that will follow later in the year. And with this, hopefully, I will be able to provide details a little bit later when we have a more detailed discussion. I'll stop here and hand over back to you, Arthur. Thank you.
Thank you very much. I mean, it's also good to have a bit, I would say, for us a nutshell and to know, okay, what we cannot say today yet, because it's potentially for those participants or the speakers, maybe not what they totally prepared, but so that we know that we will be able to provide our inputs in the near future, either towards digitization and AI part of the water resilience strategy and or towards research and innovation. So that's already good. I can tell you already, but I think we discussed it when we prepared today. There's an appetence for some of EWA member to provide feedback, to provide you with maybe a better, clearer reality, what's happening on the field, what is being used, and potentially also some blockage. That could be much. So I will ask now to all of our speakers to come back. We will now move more a bit the informal discussion. We had prepared some questions. I saw that we had 2 in the chat, so please use the Q&A question function. It's a bit easier for us to track the question and to not sure to oversee one. Otherwise, chat is fine, but a bit more complicated. and we had prepared some. But first, I would like Claire, Douglas, maybe do you want to have a word about what Soterios said, or do you want to, or you're fine, and we can start with the discussion as you want, or maybe to something that was said earlier that you, yeah, just let me know. All good?
Okay.
All good.
Okay, perfect. So then I wanted actually a question for saying both of you. So you presented now a bit what already is happening, what's doing, but maybe I had questions for you more, I would say, looking at it the other way around, and what do you see based on your experience as like the biggest barrier in deploying AI for water management or in the water sector at the moment? And yeah, what is it in your opinion, basically? What do you see more like you would like to, but you cannot for X, epsilon, yeah, it's.
Okay, I will start, but I'm sure Douglas will have the same thing. You know, we have collecting data from the field and reconciling it and have it in a historical database and exploring it means that we need to have clean data. You know, and you know that sensors sometimes they stop working, or smart meters are blocked for sometimes, and you need to fix them, so data is wrong and irrelevant. So there are a lot of development that are developed right now to use AI to clean the data and to extrapolate when we don't have. So it's a huge, of course, it's a huge blocker, but now we have it in mind, and we know that this is the key to have better models in the future. So we are really working on that part.
I totally agree. It's the poor data quality. It's a problem, and sometimes AI can help by cleaning noises, cleaning bad data, or filling gaps. But sometimes we have problems, specific problems, like I had some common cases of problems with sensor calibration of sensor that were giving for years bad data. So it's a thing that the AI itself alone, without a human, so acting, oversighting that. So the human is always recovered. Sometimes human is forgotten. So I think a human is not the human presence is not negotiable. So and another thing is, another barrier is people without skills or with limited skills. So it's interesting to, before applying AI, it's important that we have people being trained. And so AI, in my opinion, should never be replacing people. So people should be upskilled first.
Okay. Thank you very much. Yeah, I think we matched a bit one of the questions already in the chat, like yeah, many wastewater systems struggle with incomplete or noisy data. My question is, what approach have proven most effective for deploying AI under those scenarios? But I think you mentioned it as upscaling the people. And I think Claire, maybe coming back a bit to you, I think you mentioned it during your presentation. So skills, do you want to develop a bit more? What just to be starting to mention?
Yes, it's what Douglas say. The most important thing is and this is what we do at Suez. The models we develop them hand to hand with operational experts and technicians, and this is the only way we can manage to have successful and powerful and impactful algorithm to solve our huge challenges. And when I take the example of this model that we train to recognize a leak, signature sound of the leak, we do it with the operational team, and those technicians are rare, very rare actually. It's not easy to find. So if we develop some tools that can help them do the job quicker and do more kilometers than they used to do. That's the win-win situation.
Thank you. Does someone wants to, Douglas Sotiris, maybe something to add, or should we move to another questions on this?
We can move, in my opinion.
Yeah. Okay. So let me check a bit what was in the chat. So I think we had some specific questions. Let me start from the top. Okay, so that was you, Douglas. So yeah, another question: does AI algorithm available for water quality anomaly assessment using physical chemicals parameter, I'm assuming, or physical chemicals parameters? I will let one of you take it.
Yes, it's important to mention that when we are dealing with any type of data, so he gave here the example of water quality, but it's also applicable for other sub areas. So the important here is to have a flexible way to manage and work with the data, because sometimes a single sensor alone, the data don't talk too much. So if you have the combination to integrate multiple parameters, it helps to support the insights for specific situations like this one for water quality. It's a very good question indeed. So the answer is the technology should be flexible to manage the analysis of combined sensors as well, or combined
Yes.
parameters.
Sometimes we don't have the right sensor to measure the water quality in real time. So we try different approaches to use other parameters and combine them and forecast the water quality. So these are the approaches we have in R&D.
Okay. Thank you very much. On my previous question, mainly to the both of you, was a bit like, what's blockage? What do you see? So you mentioned data, skills, but actually, Sotirios, for you, more from the policy side, of policymakers, like, how do you, or what can you do to support the AI development, and especially for the water sector?
Yes. Well, the question I think here has we can approach this question from 3 points of view. The one is resources. I mentioned before we offer compute resources. I mentioned the AI factories, the gigafactories. So academia companies, startup companies can use for free these resources for training and inference. Of course, there's a process to request, but in principle, it's available for European companies and academia. And the rollout is ongoing. Some of the AI factories are already there. The gigafactories will be later in the future. Of course, there are also other more specialized infrastructures. So part of the data, the European data strategy, we have the AI labs. And talking about data, if you are a big utility with thousands of sites and so on, obviously you have a wealth amount of data there. But then if you are a smaller utility with less data resources, then the question is, have you the data available in order to be able to train models and so on? So we've seen in other domains like biotech, people cooperating together, creating data cooperatives in order to, and in return to be able to have access to better models and so on. So the AI Labs is actually about that, to allow people to create data cooperatives in order to be able to get in return access to higher quality AI models. We also have strands of work related to data. And what I have in mind here is like benchmark data. So for AI to validate performance and make sure that has meet certain quality standards, often we need to have some kind of benchmark data for different domains. Sometimes this is not fair to have the AI developer solution and the vendors creating the benchmark data, because this kind of creates a conflict of interest. So sometimes there's some kind of an independent there's a need for some kind of an independent body developing those benchmark data. And we have seen this happening in other domains. So that's also another area of application where we could coordinate actions and resources to come up with benchmark data for AI testing. And then if you leave aside the resources, there are a couple more things. For instance, in Brussels, there is the feeling that when it comes to innovation and startup companies, innovative companies, including those in AI, the investment journey is not always very easy. On the contrary, so there has been last year a communication on the European Startup and Scale-up strategy, where there were many barriers acknowledged, like the access to risk capital. You might have heard about the 28 regime. So there are obviously market failures there that we'd like to address, especially in Europe. And it's quite likely that with the strategy on research and innovation, we might be delving more into that problem, particularly when it comes to innovation around water, and why not water and AI. And last but not least is the skills part that was mentioned a lot. I think this is really important. When it comes, I mean, the new tools obviously bring needs for new qualifications, the upskilling that Douglas mentioned earlier. And part of the water resilience strategy, actually, there's a task on the Water Academy. And there are links with the European DIT, the European Innovation and Technology Institute in Hungary, where most likely we will be looking at the skills, and why not skills related to AI and water as well. Of course, these things to be defined, but I think it should be part of the upskills agenda that we are discussing here. Thank you.
Thank you very much, Sotirios. You really took the word out of my mind. I also wanted to mention quickly, because all of you now mentioned skills. And yeah, we hope that the EU Water Academy will also mainly focus on professional skills. And of course, that AI will be a good component of it, and to train the workforce for it, and how to use it, and how to increase its efficiency, of course. I think we had a couple of questions in the chat that were some or less like a bit, I would say, was a similar on, okay, one was really specific. So can you integrate data from water meter with building leaks detection? And the other one was more, how can you adapt your models from customers to customers, so from clients to clients, and to make them more precise? So I think we had 2 or 3 on this. So maybe if you can take those 2 before we slowly move towards the end. So.
Okay, so yes, the use of smart metering data is really a game changer in this domain, and we use real-time consumption data to detect abnormal patterns, abnormal consumption patterns, and to act quickly on the and mainly we inform the citizens that there is an abnormal situation there, and that they should do something about it. As for the same way we develop models, it used to be based on very clear rules defined by the expert in water consumption and water meter data, and more the AI is learning what is an abnormal situation compared to just a person going to his second house for vacation. You need to train the models, and they are smarter and smarter because we have so much data now. We operate 6 million smart metering in the world, so imagine the amount of information we can get from that.
Thank you. Douglas, do you want to add something on this, or?
Yes, sometimes we got questions about how can we integrate a specific data from a specific vendor. So giving a generic answer is not only one endpoint that you should analyze. So sometimes you have to also understand if the vendor offers ways to platforms to connect the data to. So if the platform provides APIs or endpoints to connect, this is the first thing to be analyzed. So planning the framework, analyzing not only the technologies that you're using and the openness of them, and I'm going to try also to answer another question about the usage of parameters of water quality, and sometimes is limited. So the way we are planning the framework for AI is also interesting. Understand the data we have. So then the consumption of this data with AI should be tailored in function of the availability of the data. So sometimes you have to work with limited data, which is very common. Then you have to adapt your project to the availability and the technology we have.
And there is in complement to what you say, Douglas, I see a new trends. Mostly, I saw that in startups that start to work on models that are trained and adapt to customer specific data very fast and quickly. So instead of training a model for days now, with new technology, they do it in a day, let's say. So there is this new trend of adapting very quickly and train models, smaller models, to the context of the customer. This is going to be happening a lot in the future as well.
Okay. And I think one last question then for you, maybe final words. Yeah, what do you see as what would be like the groundbreaking that you potentially see coming or not actually? Yeah, like maybe one
For
short
me,
conclusion on your side, yeah, for each. So Claire, you can start.
it's really hard to predict what's going to happen with the AI. It's moving so fast, but I guess that in the future, like Douglas is showing the first step of that, but in the future we will have a real digital twin of the water resource available all around the globe, and we start to see some tools that shows you what is available and what will be available, how we will be able to produce drinkable water. Will we have enough? So we will have real-time view of what is available, what is not, and what we can do with it. I guess this is the future in the water domain, out of so many other possibilities. But maybe Douglas has a better one.
I think that today we are seeing a lot of usage of the larger language models combined with sensors for generative AI, and I think that in the future will be now this being expanded by including also the physical models. So then we can connect sensor data with existing data like GIS and hydraulic models. So today we have a lot of people already, clients already using digital twins. So now imagine combining LLMs, the generative AI, agentic AIs together. So I see in the near future, I think medium and long-term future is difficult to predict, but on the next years, the combination of a generative AI and with digital twins is something coming more frequently, in my opinion.
And the collaboration with European institutions, like you said, having access to computing power and cyber security and sovereignty of our data will be crucial in that journey, I guess.
So Thierry, do you want to have last words?
Listening to Claire and Douglas, I think the thought that came to my mind, and I'm going to be open, is that okay, I have a little bit of experience from the water sector, despite I've never worked there. In the past, especially, we had this perception of the water sector being a little bit more conservative, let's say, in comparison to the other utilities like energy. Let's put it like this. But now, listening to you, I think there's a really opportunity to leapfrog ahead because the water sector has a tradition in the physical models, the digital twins, the physical models. I think this would be quite a big advantage because what the generative AI is lacking, and Douglas alluded to that, was exactly this validation. You have on the one side the generative AI, the language-based models, and so on, which lack the real-world validation of what they're saying. So I think really the combination of the language, generative AI, and vision, together with the physical models of the real world models, I think they can leapfrog the water sector actually ahead, creating reliable solutions that they don't hallucinate and they can be relied upon to deliver solutions. That's my thought. Let's say listening to the panelists. Thank you.
All right. So I think we'll finish on those positive words from the three of you. So thank you again. Let me just quickly share my screen again. But thank you very much, everyone. As mentioned at the beginning, so this webinar is being recorded. It will be updated on an EWA YouTube channel in the upcoming days. You will receive the presentation for the speakers from the slides. We would like to inform you, as we said, so our upcoming activity. So IFAT, do not hesitate in May to use the EWA code to register and get a free entrance ticket. So we'll have also an upcoming webinar as part of an Interreg Alpine Space project on groundwater challenges in urban area. We'll also have our last webinar as a preparation to IFAT on desalination. So just check our website for more information, our social medias, YouTube channel. You can register to our newsletter. And when you will leave, you will get an automatic survey. Please take the 2 minutes to reply. How can we increase the quality of our events? So again, thank you very much to Claire, Douglas, Soterios.
Thank you.
We finish now on time. So thank you again. Do not hesitate if you have any question to the speakers or to us, send it per mail. And I wish you everyone a good rest of the day and of the week. Thank you very much.
Thank you.
Bye-bye.
Bye.
Bye.
Bye.